I would like to welcome everyone to our presentation, PHPP and Rhino, an introduction to IDF2PH. I would like to welcome Ed May, who most of you know as an architect, passive house enthusiast, consultant, and also a passive house software developer. And so in this session, Ed will present a new software he developed and the workflows which allows designers like us to create a PHP and an energy plus calculation from a single building information model. So without any further delay, I would like to welcome Ed, and I'm looking forward to your presentation. Thanks, Ed.
For being here. It's awesome to see so many familiar faces and names. So thank you guys so much for being here. I honestly thought we'd only have like 4 or 5 people attend this session. So it's cool to see such a big group, see so many folks interested. So yeah, thank you for being here. And thanks Andreas and New York Passive House, Caleb, everybody for setting this session up. You know, it's great to be presenting here as part of the New York Passive House crew. So I'm going to be talking a little bit today about some of the new tools that we've been developing inside of our office and how we're using them to help our own workflow. And we'll talk a little bit about you know, how they work. And I should note up front, these are all open source free tools. So if you're interested in any of them, you know, feel free to grab them and give them a whirl. You know, these aren't like official software or anything. It's not something you buy. These are just tools that we make available. You can get them all from our website, or I'll show you the other websites and places to get these tools. So I'll show you a little bit about how it all goes together. And then I'll try real hard to make sure that we keep maybe 20 minutes at the end for questions. I'm sure folks have lots of thoughts or questions. I'm really keen to hear everybody's opinions and sort of reactions to some of the stuff we have here. So I'll definitely try and leave some time at the end there. So for those of you I don't know already, you know, it's awesome to meet you. My name is Ed May. As Andreas said, I'm a partner in the consulting firm Building Type. We're based out of Brooklyn, New York, just a small passive house consulting firm here. And I'm a trained architect and passive house consultant. And I also get to do an awful lot of teaching. So I have the privilege of teaching for North American Passive House Network, New York Passive House, and Passive House Canada. But as I said, today I'm going to be talking to you about some of the new digital tools that we use in our professional work as passive house consultants. And the goal of these tools is to help us do a better job in our professional passive house modeling and consulting work. So before we actually get into any of the tools, I actually want to start with 2 problems that we're trying to solve. So why are we so interested in these topics, and why are we spending so much time working on these issues and tools? So there's two related problems that I'd just like to start with and sort of highlight. So first of all, when it's done well, I think that dynamic hourly or sub-hourly time step models, you know, things like the Department of Energy's Energy Plus, can yield really, really incredible, amazing insight, super detailed results about the performance of our buildings. I think these are really useful tools. However, I think that these tools are often very difficult to utilize correctly. And I think that especially for teams which are already spending a lot of time, energy, and frankly money to create PHPP energy models, creating some duplicate dynamic energy model in yet another software package is probably not feasible for most teams. And I think this is really unfortunate, because I think that the Energy Plus and Open Studio ecosystem is super powerful and has all sorts of really useful tools which could help us as we design our passive house buildings. For instance, if we could hook into the existing library of Open Studio measures, that would be a huge win for passive house consultants, right? That would really help us advance our modeling and our process. So that's one problem. Now, I see a second problem as well, among many, but I see a second problem in that when it comes to passive house energy modeling and certification process, I think that we do have some really amazing tools, and I thank all of the developers for building these tools. I think they've done an incredible job. Things like Design PH, BIM to PH, Passive Link, these are incredible tools. But unfortunately, none of these tools actually gives us a complete building information modeling and passive house energy modeling toolkit, which is capable of executing a complete passive house energy model. You know, even the best of these tools, Design PH, etc., they still leave us finishing and editing a bunch of stuff over on the PHPP side, or excuse me, over on the Excel side, in particular when it comes to things like mechanical systems and cooling and variance and shading, etc., etc. So all of these existing workflows leave at least one or another important feature out. And what this means in practice, or at least what we have found, is that for us, some information is encoded in the 3D model, and some information is entered directly in the Excel model. Now, I think that this dual source workflow is a real problem. I know it's a problem for us, and I would guess that it's a problem for many. I think it leads us to make errors. I think it leads us to make lots of mistakes. I think it leads to longer model times because of the extra confusion. And I think it just leads to a lot of frustration amongst the team because you don't remember where that information lived or where it got entered or where it came from. I think it would be much better if all of the building model data came from a single source in order to eliminate ambiguity, reduce errors, as well as simplify the process and streamline the entire modeling effort. So there's at least two problems there that we're trying to overcome with some of these tools that we've been building. We'd like access to this world of dynamic energy models, and our existing building information modeling tools are incomplete in ways that tend to hinder our ability to work really quickly and accurately, especially on really large or complex projects. You know, that's where these issues really come to the fore, and where we really see them most prominently is when we start to work on really complicated buildings that change rapidly. So this is where some of the new tools that we've been developing and utilizing in our own office come into play. In particular, there's this one toolkit that we've been calling the sort of Passive House Tools kit. And within that, we have this IDF2PH tool. This is a free and open source toolkit. So again, I want to stress this is not software that we're selling or something like that. This is just tools that we use in our office, and you're more than welcome to use them as well if they seem useful to you. This tool allows us to much more flexibly connect our own PHPP models to a more complete building information source model. So this IDF2PH toolkit is capable of creating a full dynamic energy model using the Department of Energy's, US Department of Energy's Energy Plus engine. And at the same time, we can create and control a complete PHPP model. So this toolkit allows for users to super easily work through the Rhino, Grasshopper, or Dynamo environments using Rhino inside if you want to work in Revit. And this means that we can have a single source model drive our entire simulation and certification process, which is going to really reduce, or has for us anyway, really reduce the modeling time, the complexity, and most importantly, eliminated a lot of errors. So the IDF2PH toolkit works by piggybacking on top of some other really amazing free and open source tools. In particular, there's this one toolkit known as Honeybee, which is a tool set made by the Ladybug Tools team, and we'll talk more about that in a few minutes. So first, we talk about the IDF2PH and toolkit and what it's made of. It's got three main pieces. There's a whole new set of data management and input tools, which we use during our Rhino 3D modeling phase. So as we're building our building information model, there's a whole set of new tools that we use to encode data into that model. Second, we have a batch of new tools which enable us to connect to the existing Honeybee Energy Plus tool set. We piggyback on top of it. And then this allows us to create both that Energy Plus model and a PHPP model, all from within that Rhino and Grasshopper model, and all from that single source building information model. And then last, we have a new sort of adapter or exporter, which is capable of reading the Energy Plus IDF file. We'll talk about what that is. It's the sort of source file for an Energy Plus model, and the Honeybee model data, and then pushing that out in real time to a PHPP Excel model. So we'll see how all of that I'll show you how all of that sort of folds together and connects together. So let's look at those one piece at a time. So the very first piece of that toolkit are a bunch of new Rhino side tools, which allow us to manage PHPP relevant data in our Rhino geometry or our Rhino model. I like that process very much. The tool is flexible enough to allow you to do all of this data application and parameter assignment in Grasshopper if you prefer, or Dynamo if you prefer to do it that way. That's fine. I think that makes for messy and kind of complicated definitions. I prefer to manage data over in the sort of Rhino side. But you know, the tools are flexible enough to allow you to work however you want. But this includes things like windows and opaque surfaces, material assignments, room level information, TFA, lighting information, lighting controls information, thermal bridges, domestic hot water components, recirculation systems, all sorts of different elements can be created. Smart objects can be created inside of Rhino using these new tools. So these custom tools allow us to sort of manage this data in a really user-friendly way. You just click on the thing and then you get a bunch of information, very Revit-like in that sense, right? You sort of have a living model with all the information encoded into it. The model process is really straightforward. You have a bunch of new tools, you have a bunch of geometry, and then you assign parameters to the geometry. Very design PH in that sense, very much like any other building information tool. For instance, when we work with windows, we can easily set all the various parameters for the windows using these tools. So as we build our surfaces and build our surface geometry inside of our Rhino model, we can just tag and associate all of the information inside of this tool. Now, once that part is done, and again, you don't have to use that part. I like to use that part. I find that to be a really useful way to work. But again, if you'd rather do everything in Grasshopper, that's totally fine. The tools are flexible enough to let you do that. But the second piece of the toolkit here is a bunch of new Grasshopper definitions or tools that allow you to do this Energy Plus and PHPP modeling inside of Grasshopper. I think there's something like 50 new components that we've written that allow you to do this type of modeling, all the way from opaque surfaces and windows up to things like really complex mechanical systems, schedules, and the like. Now, just briefly, if you're not familiar with the Grasshopper environment, Grasshopper is part of the Rhino 3D modeling software, and it allows for what we call visual scripting. It's something like a little sandbox that allows you to create and reuse scripts within Rhino. So as you see here in the Grasshopper world, the data is going to flow typically from the left to the right. And in a Grasshopper definition, you have input data that then flows into some user-defined manipulations or functions. And then these manipulations can range from super simple to really, really complex. And as you see here, the input data can flow into multiple functions or manipulations at once, and then all of those outputs can then be used for subsequent operations, subsequent functions. These definitions can be reused as many times as you want, and they allow for lots and lots of flexibility. Now, of course, playing with arithmetic in Grasshopper is fun and all, but the real power of this tool is that we can connect it back to that Rhino 3D environment. We can either create new geometry and data, or we can read from existing geometry and data, which is inside that Rhino model. And we can then pass that data into a series of functions and tools and manipulations before recording those results. Now, briefly, Honeybee is the name of a set of open source free tools, which are pre-made Grasshopper definitions, and they give us the power to create an amazing array of building simulation and performance assessments. Things like daylighting, thermal comfort, glare, condensation, envelope, thermal performance, with therm. All of these things can be assessed and visualized using this really powerful toolkit. In addition, Honeybee creates Energy Plus dynamic models from Rhino geometry. So we can use this existing framework. We don't have to reinvent this at all. We can piggyback on top of this existing framework. We can get the benefit of getting a complete Energy Plus model, all of the functionality of Honeybee, and a PHPP model at the end. So we're going to reuse a lot of the existing workflow and functionality of PHPP. We're going to piggyback on top of it. This is going to be done by using a lot of these new Grasshopper components, and these things are used in line with the existing Honeybee components. So in order to extend and expand those basic Honeybee workflow, we're going to add some new functionality. For instance, when we create a new thermal zone, before you pass that geometry into the normal Honeybee components, we first pass it through one of these new IDF2PH tools. This is going to add a whole bunch of new information, a whole bunch of new classes, a whole bunch of new methods and functions to those objects. It's going to add a bunch of new intelligence and a bunch of new functionality to those objects. The same logic is going to apply to things like windows or mechanical systems, simulation setup. Basically, anywhere in this chain of work, you're going to sort of fold in a couple of strategically placed new components, and that's going to allow you to create these really robust building information models, which will then flow into both the Energy Plus and the PHPP. So then lastly, the last piece here is this sort of adapter or exporter, which allows us to take the simulation file built in Rhino and Grasshopper. So take the IDF file, which is the Energy Plus blueprint file. We take that and we can convert it into a PHPP file. Now, technically, you don't have to create this in Grasshopper. This tool can actually take an IDF file, which is created in any tool. You can write it by hand, do it in Design Builder, do it in whatever tool you want, and then you can take that IDF file and convert it into a PHPP. But this is sort of custom made to work really well with the Honeybee tools, and it adds some additional functionality if you use it within the Grasshopper world. But you don't have to by any stretch. It can operate sort of independently as just a straight IDF to PHPP exporter or adapter. Really briefly, if you're not familiar with an IDF file, if that's a weird term, if that's kind of a confusing term, it's a type of file. It's just a simple text file, honestly, which forms the input or the sort of blueprint for an Energy Plus simulation. So Energy Plus is a free, a really powerful energy simulation engine, which is maintained by the US Department of Energy. And it uses these IDF text files as the blueprints, as the sort of fodder to enable and create the energy simulations. This file is used by that simulation engine during execution, and it gives it all of the information that it needs about your building. All the surfaces, all the climate information, all the materials, all mechanical systems, all of that. It's all spelled out in this text file, this IDF file. And this IDF file is what Honeybee is actually creating. So that Honeybee tool actually creates this IDF file, and then you can go execute it however you like to execute your Energy Plus simulations. You want to use EP Launch, you want to use Open Studio, whatever. You can then go off and run these energy simulations however you like. But for our purposes, what we want to do is take all this information and then pull it into a PHPP. So we get this matching PHPP, which is built off the IDF2PH. So what does that all that mean? Well, what it means is that once we've built out the connections, once we use our Rhino model and our Grasshopper toolkit to build up our pipeline, what we end up with is a really flexible data stream where the geometric and parametric data, which is encoded into our Rhino model, is going to stream through in real time into our PHPP model. As you can see here, if we take a super simple box model geometry and its PHPP representation, and we really quickly build up the geometry, as soon as we have a valid Energy Plus model, which basically means as soon as we have a floor, the PHPP updates automatically. We can also modify any model parameters such as names, U values, mechanical systems at any point. And all of that's going to stream live into our PHPP modeling environment. What this means in practice is that it gives us super fast feedback of our design decisions and a lot of transparency into the model. We also get the complete Energy Plus and PHPP model without any ambiguity as to the data source, which is going to simplify the data management and reduces our errors across the board. For instance, if we want to add a couple windows, I can very quickly just hook up a window here. I now have one window which is pushing through into the PHPP. And if I want to edit that window, it's as simple as using my native Rhino tools. I can come in here and just name the object. Those names will flow through. And if I want to resize it, I can use any of my typical Rhino functions. If I want to scale it, if I want to make a duplicate, all of these things are going to flow through automatically into my PHPP. So I can add and subtract elements at will and get live results in my PHPP energy model as to the implications of those design decisions. And remember, in the background, alongside the PHPP that you see here, you get a complete Energy Plus IDF file, which is going to match all of the geometry, all the materials, all the constructions, all the schedules, which are shown in the PHPP. You could take this dynamic model, go off and do all sorts of evaluation and design and modeling at any point. So that's the basics of the tool. We can go into some of the, I'll go into some of a little bit more depth on some of the individual components in the tool now. But that's the basic idea behind the tools that we're using here. But let's take a look at some of the individual elements here. We talk a little bit about some of the details of how these different pieces work. So first of all, in terms of the Rhino side tools, so we have a whole set of Rhino side tools that allow us to add parameters, add information onto the geometry in our Rhino file, right? So that the whole idea here is that we build geometry and then we apply or add information to that geometry. And it's as simple as selecting a piece of geometry and clicking one of these buttons. You get a bunch of graphical interfaces which allow you to select information from drop-down menus and the like. And it's very kind of straightforward. I think very much like Design PH or Revit in that sense. You sort of assign information to different geometric objects in your Rhino file. This includes things like windows. Obviously, it's going to include opaque surfaces. That's all going to be really important. It's also going to include things like TFA surfaces, so interior room geometry, room data, volumes, that kind of thing. Thermal bridge information, so we can tag individual edges with thermal bridge information. Domestic hot water piping, so I like to do a lot of stuff in Rhino, so I actually draw in piping using simple curves. You can tag that with all sorts of information about diameter and insulation and and the same goes for ducting, so we can also do a lot of ducting information there. Again, I find it's easier to do that in the Rhino side, but there's no requirement that you do. All of these tools will work if you want to build up that geometry or those components parametrically inside of the Grasshopper environment. That would also work just fine. One of the other pieces that that we have here is a sort of native library that we use to create and maintain our sort of libraries of things like construction types, glazing types, window frame types, et cetera, et cetera. Right, so we have a whole bunch of different methods for managing that information inside of our Rhino file. So we can also connect that out to other PHPP files. So you can easily import that data from PHPP files or the like. And you may wonder where all this information is living. And just, for those of you who are interested in the sort of guts of the stuff, Rhino 6, so Rhino version 6, has a really nice new functionality which allows us to easily host any information we want inside what's known as the attribute user text dictionary. So every object in Rhino has the ability to hold these parameters, hold a set of information. Right, which is super useful because we can now use that functionality, we can use that ability to basically hold on to all of this interesting information. And then we can pull it out later on at any point. So this is nice new functionality, which is available in Rhino 6 or better, which is we're making use of in the tool here. Briefly, when it comes to those library functions, so I said we have this kind of custom library management tool that we're using internally. Or using inside of the Rhino file, which allows us to create databases of all of our different assemblies, things like construction assemblies for different materials and et cetera, et cetera. So as you can see here, this is one project that we've got in progress, and we've got all of our different construction assemblies loaded up here with their U values and thicknesses and interior insulation flags and the like. This is one place where I know we need to build out the tool in a little bit more robustness. Obviously here it's quite simplified. This is very similar to maybe the components worksheet in the PHPP. So all you have here is the ability to enter a total U value or a total thickness. So this is different than the sort of assembly constructors that we have inside of PHPP. In our office, we don't use those assembly constructors. We do all of our assembly U-value calculations in Flixo. We do a graphical method for doing those calculations. I'm trained as an architect, and I like pictures. I don't like lists of numbers. So when I calculate U-values for walls, I like to have a picture of the wall to show me the studs and the spacing and the thicknesses and the da-da-da-da-da. I find it so much easier to do all of those calculations outside of PHPP or outside of Rhino and calculate just a total U value. So for us, this works awesome. We can just take those U values and bring them right in. I totally recognize, though, that if you're using the PHPP constructors, this is not great. And so what we have done here is we allow you to actually import data from PHPP. So if you want to use PHPP to build your assemblies, you can see on the bottom of the sort of screen here, there's an import button. And you can basically just point this at a PHPP and all of that data will get pulled in from a PHPP. So you can still use any PHPP to essentially build your assemblies or build your database there. And then you can always connect it to this guy here. Same goes for, so that's all we use that for opaque assemblies. Same is true for windows, of course. So you got, things like window glazing, window frames. Obviously, this is going to match your PHPP or your WFI setup, right? Same kind of data inputs are required or needed here. One thing, just to note briefly, note that U value, that's a really long number. That's a weirdly specific number. And that's because sometimes, depending on the products that we're working with, I don't enter information in metric units. Instead, I enter information in IP units. And so the way that I've built the tool is that by default, everything's in metric. The Energy Plus simulation's all in metric. Honeybee's all in metric. So those other tools that we're working with are all in metric. So by default, it works in metric. But sometimes I like to enter things in IP. And so what I've done is create the tool in a way where if that's what you want to enter, just say it. So if you want to enter an IPU value, just say 0.11 IP, and the tool is smart enough to know that what you meant by that, and it will convert, it'll do all the conversion for you. And that's true mostly, I think that's true across the board in pretty much anywhere where you're asked to input data. If you just say, oh, this is inches, or oh, this is IP, it's smart enough to do all of that conversion for you. I don't have anything where like you can change the visibility so that like globally you see inches or anything like that, but you can certainly enter information as IP units at any point and it'll do all that conversion for you. So that sometimes makes our life a little bit easier, depending on the types of products that you're working with there. And then window frames, of course, very similar to the way that we work with, products in PHPP components or Woofy. You're going to enter all of your various frame widths and frame U values and side G values, et cetera, et cetera. And again, all of this can be imported from PHPP. So you do not have to write this out like one number at a time. You can do it all in PHPP and have kind of a database or something, and then just import it all into your project. So that's totally fine as well. One thing that people always ask us about is the shading side, right? So that's one thing that a lot of folks want to do in the 3D modeling side is the shading evaluation. So we've actually, for our projects, we built 2 different methods for doing shading. So I totally understand that for certification purposes or for, verification purposes, we want to have the old-fashioned PHPP style. So I totally get that, right? We want to be able to do that thing where we find the distance away and the distance above and the distance to the side, all of those kind of distances. I totally get that, right? So we have a tool that does that basically every window sort of looks out into the scene, finds all of its obstructing or shading elements, basically calculates the distance out, the distance up, the distance, horizontal, all of those usual distances that we use in PHPP. Now, the interaction is relatively straightforward. So, if you have a simple scene like this and you want to put some, horizontal overhangs on, it's as simple as dropping in the horizontal overhangs. It's all operating in real time and pushing all this stuff out to the PHPP. If you want to put in, horizon obstruction objects, it's as simple as something like that. And obviously, you can use any of your Rhino tools to make modifications and manipulations to any of that at any point. And again, this is all operating in real time. So it's pushing this out to PHPP and you're getting results on your overheating and your cooling energy and heating energy as you're making these modifications, as you're sort of scrubbing through and making these changes. So that's one method of shading. We built that exists. You can absolutely deploy that at any point. That's basically going to mimic the old-fashioned Design PH1 or 1.5 or the old-fashioned PHPP method. But of course, as most people probably know on this call, Design PH2 has significantly improved the shading methodology. So there's a whole new process for shading, which uses shading mask method, a shading mask method. Now, I would love to implement that same method in our tool here, but I have never been able to find anyone who has published either an explanation of that algorithm or validation of that algorithm. So I have no idea how they do it. It has not been published. It is not part of the PHPP. It's entirely internal to Design PH, and Design PH is all encoded or compiled. You can't actually get at the code there. So there's no way for us to know exactly how they do that method. So unfortunately, I can't recreate that specific method. That said, the Ladybug tools and the Honeybee tools allow all sorts of really powerful shading assessment methods, which I think we can use to do even better shading than this new Design PH2 methodology. And by better, mostly what I mean is faster and more accurate. So I think we can use these existing Ladybug radiation analysis tools to do much, much stronger, more robust, and more effective shading calculations. So we have built a tool which allows us to do this type of assessment internally for our own projects. I do want to note, though, very strongly that this method has not been validated or approved by anyone. So no one at PHI, no one at PHPP, no one has looked at this method and approved this method or thinks it's okay. I personally have not done a really robust comparison of Design PH2 and 1 and these Ladybug shading factors. I've done sort of back of the envelope assessments, enough to satisfy my own curiosity and my own questions about whether or not this works. I feel confident in it, but I have not validated it in any way that would satisfy, a really rigorous assessment. And so that's something that's on our list. I would love to do that someday. I think it would be useful and important, but we have not done it. But the tool exists. You can absolutely deploy it. I think it works great. But again, I don't have proof of that. And so that's something that's on our list. I would very much like to validate that and see whether that's really working or not. But the reality is that we're using it internally for our own projects. Again, I feel really positive about this method. It gives us incredibly detailed results, and I feel very confident in the specifics. So we're using it on our own projects. It's a single family home from a month ago that I was working on. I feel confident in using this specific method to calculate shading factors for our assessments. But again, that has not been validated by anybody outside of our own office. So, take that all with a grain of salt, put a big asterisk next to all of that before you start deploying it on, anything other than an internal project. If anybody wants to work on validation with me, let me know. We could get to work on it. That's, it's one of those projects that's always in the background. And someday we got to do. In any event, we're using these methods internally, and I think it gives us a lot of information. This is a graphic from a client report. It allows us to show our clients, who are often other architects who are asking how to make better designs. It allows us to show our architect colleagues, a lot of very detailed information, and we can make, I think, smarter decisions around shading and deploying shading and overheating risk, etc. And obviously doing things like dynamic energy modeling. It's going to give us a much better window into things like overheating risk of critical rooms than the single zone PHPP ever could, right? So that's going to be really impactful and powerful as part of our toolkit here. We also, of course, have the ability to model lots of room level information. One of the things that really frustrates me about the Design PH tool, I love Design PH. I love Design PH. It's an amazing tool. They've done an incredible piece of work there. But one of the things that I find really lacking about it is that I don't have the ability to manage room level data. And again, where this really shows itself as a problem is when we get into big, complicated projects. I have a project with literally hundreds of rooms, and somebody changed the floor plan and is asking me to update the model. And now I have to go through and say, well, did I update that one? Did I update the bedrooms and all the bedrooms and all the kitchens? And you have to go through, and it's an incredibly laborious process. So I prefer to model everything and just let the model data flow through automatically. I don't ever want to be in the situation where I'm checking and updating, spreadsheets of lists of room areas or room volumes or something like that. That should all be done by the computer. A person should never do that. So what that means in practice is that we're going to model the interior spaces of our buildings. We're going to be able to tag these with all sorts of different information, room numbers and names, TFA factors, fresh air ventilation flow rates. Again, this allows you to input either IP or SI. It's SI by default, but if you want to put in CFM, just say CFM and it'll do all the conversions for you. And then of course, non-residential information, things like room usage categories, if it's a non-residential usage, lighting control systems, motion control systems, all of these things can be applied and managed on a room by room basis. And then of course, all this data is going to flow through into that PHPP. So in terms of systems, we'll talk for just a few minutes about systems, and then definitely I want to preserve a few minutes here to take some questions. If anybody has any questions, or I'd love to hear your thoughts. Fresh air ventilation systems, of course, you can make as many fresh air ventilation systems as you want, apply them to different zones. It's smart enough to combine everything together. You can do ventilation ducting, you can do ventilation units, you can do exhaust ventilation systems, you can build systems and apply systems to different zones. All the inputs can be either SI units or IP units. So again, if you want to input inches, just say 4 inches for diameter. If you want to input metric, just do that by default, millimeters or whatever. And then the other thing that I want to note with all these systems is that you don't have to put in things in numbers like this. You can, if you like, do all of your encoding back in the Rhino side and just reference in the geometry, and then the components will pull all that information off the geometry. So you don't have to encode all this information in Grasshopper. You can easily sort of pull all that information out. So for instance, when it comes to something like domestic hot water systems, you can put together tanks and branch level piping and recirculation level piping and usage profiles. And again, you can either input information directly as numeric values in the Grasshopper environment, or you can reference in that geometry from your Rhino file. And if you've encoded data in the Rhino file, all that data will get pulled out of that geometry automatically and then passed through to build the system. Right? So we can build these hot water systems. You can build quite complex systems. PHPP allows you to do, 5 banks of piping. The tool here allows you to do multi-zone models, which we'll talk about in a second, where you can have a different, domestic hot water system for each zone in the model, and, have these things combined together in all sorts of different ways. So you can build reasonably complex mechanical systems, both on the ventilation side and on the domestic hot water side. And then, of course, we have the ability to model reasonably complex, although I will say when it comes, compared to something like Energy Plus, all of this stuff is quite simplified, but this is all the PHPP method, right? All of these tools that I'm showing here have been built to get the right data into the PHPP. And as we all know, the PHPP mechanical systems are pretty simplified compared to something like the Energy Plus mechanical systems. So just take that all with a grain of salt as well. But we can build heating and cooling systems. We can build heat pumps and boilers and da. We can build ventilation systems, domestic hot water systems. All of that stuff gets managed in the Rhino file, and it all streams out to PHPP in real time. There's no ambiguity. You never go into the PHPP and type in a bunch of values for your hot water system. You're going to manage it all in the Rhino file, and then it's all going to automatically flow through. And then lastly, we have been using this for larger projects which have multiple zones. So one of the things that we really wanted when we started working on this type of project was, okay, I have a tower on a podium. Sometimes I'm using the same materials between the two. Sometimes I'm using same systems between the two, but I actually want to branch them to separate PHPPs at a certain point, or maybe I want to separate the different zones of the building to multiple PHPPs. But I still want to kind of be working in one file. It's one building after all. So this tool allows you to do that really easily. You can either combine multiple thermal zones. So, different thermal zones that you might have in Energy Plus, you can combine lots of thermal zones, and then you can break them back apart and say, take these thermal zones, put them in one PHPP, take these thermal zones, put them in a different PHPP. And you can actually branch off multiple PHPPs from the single source, which is really helpful when it comes to things like mixed use buildings. You have a tower on a podium, you have different use types inside of your building, all of that kind of stuff can be pretty easily managed using these tools. Oh, and yeah, and of course at the end of all of this you get that Energy Plus model at the same time, and it matches the PHPP. So I like that a lot. So then you can go off and execute your simulation in Energy Plus at any point. If you want to do a localized thermal comfort assessment, you want to do an overheating risk assessment for a critical room or something like that, you can absolutely go off and do that at any point because you have that matching Design Plus model. So the key bits here, I should have noted also, this automatically works with either the IP or the SI PHPP. Our office, we work in the SI PHPP, so that's what it's going to work best with. But I think we've tested it pretty well. I think it works pretty automatically with the IP version of the PHPP. So if you want to work in feet and inches, it'll automatically output everything as feet and inches to your PHPP there. That's fine. Just depends on which PHPP you hook it up to. All your geometry, obviously, all your shading, U values, materials, windows, ground, didn't talk about, but there's all sorts of ground components, thermal bridge components, room by room modeling, TFA, appliances. We've built in all sorts of stuff for appliances for both the Energy Plus side and the PHPP side. One of the real headaches with Energy Plus is trying to model residential appliance systems. Those are often not present in a lot of the libraries. So we've built some kind of matching libraries there. Mechanical systems, multi-zone systems, and then I didn't really talk about, but we've got a bunch of automatic PDF outputting stuff. So you can take all this data and sort of put it into PDF, pages. If you're doing certification work, you need to print out all your thermal bridge lengths or something like that. So you make a little graphic of each thermal bridge and highlight it, that kind of stuff. So we can automate a lot of the output for TFA and floor areas, thermal bridges, et cetera, et cetera. And of course, you get that dynamic model at the same time, which I really like. We use that for a lot of stuff. I know that was long, but if any of that sounds of interest at all, feel free to go to IDF2PH.com. We've put all of this stuff up online. You're more than welcome to give it a try. It's all free. It's all open source. It's an open source project. It's a early version of the project, so I expect that you'll find some bugs or two in there. Do not be surprised if you find a bug or two in there. This is not professionally made software. I'm just an architect making stuff. Don't yell at me if you find a bug or two in there, or please don't yell at me. But you're more than welcome to try it. So, feel free to give it a try. And I would love to hear your thoughts or opinions, or if you guys have feedback about, it would be awesome if it did this or that. We've already gotten some good feedback from folks, which is really useful as we kind of calibrate these things. Mostly, like I said, we build them so that we can use them internally for our office, but I'm happy to share them with everybody as well if they're useful. I would also note, if you're really interested, I have a whole YouTube series that I put up. I sort of recorded a bunch of screencasts of me walking through the usage. So if you want to see the usage there's a whole 4-hour YouTube sort of tutorial series there. You can get to all that through that IDF2PH website there. And I've been sort of thinking about this one piece, this IDF2PH, as part of a larger Passive House Tools sort of project that we're in the middle of. So IDF2PH is one piece. We have in mind all sorts of other pieces for sure. So in terms of next steps for this thing here, I personally am right in the middle of a big rewrite. So if you're familiar at all with Ladybug Tools, you know that they just came out with a brand new version in October. and it is a substantially different version. It's a substantially more professional and more refined piece of code. It's incredible, but it does mean that I have to sort of rewrite almost everything, and so I'm right in the middle of that as we speak. So I'm updating everything to work with this brand new version of the Ladybug Tools software, which again just came out in October. So that's ongoing. I'm sort of cleaning up everything as we go. It's going to be a lot faster. It's going to be a lot more reliable. It's going to work a lot better, and it's going to support the new version of those Ladybug tools. I would expect I'll get done with that, I don't know, probably by the end of the year. You know, it's nights and weekends work, so whenever I can find time to do it. But probably by the end of the year, we'll have that completed. We have a couple of projects in our docket that might need me to do that faster, so I might actually have to expedite that and sort of do that a little faster. Enhanced outputting. So the PDF thing, the writing PDFs is a little bit primitive right now. I want to refine that and do a better job with that. You know, squash some bugs and include some missing pieces. There are some pieces that are not there. So, you know, some folks have already pointed out, oh, hey, you're missing this tool or that tool. So, you know, there are just a few places where I'd like to build some other elements, and then a lot of validation stuff. So, you know, we really need to validate this tool, this trees thing. We need a better method in general for modeling trees, you know, variation and tree canopy cover and opacity, and how we model that. So there's a lot of work to do there, to be honest. And then additional exporters, you know, people are always asking us for, you know, can we do the same thing for ResCheck or ComCheck? Can we export to Woofy? We have a proof of concept for Woofy. We've definitely done that, so we can get geometry into Woofy. That's pretty easy. Managing materials is a little more challenging, but we'll figure that out at some point. So we can definitely do that. So you could branch off to Energy Plus and PHPP and Woofy, and maybe even ResCheck or ComCheck at someday. We'll get those when we get there. And then other languages, we've had some requests already to, can you convert this to, you know, can we use this with the German PHPP? Right now, no. Right now, it's assuming an English language PHPP. It has to work with an English language PP at the moment, but there's no reason that we can't do that adaptation. So someday we'll get around to that. We'll make it work with all that stuff. So again, I just want to stress here, this is a big open source project. So if anybody is interested in this, if anybody feels like, oh, I would like to contribute to that, that would be super cool. We're just making these things because we think they would be useful for folks. Again, this is not software we're selling. It's a big open source project. So if you have ideas, you have alternate workflows that you want to contribute, you want to code, you want to write some new features, you want to build some components, and you want to test or validate any of this, you want to work on documentation, tutorials, how-to guides, anything like that, that would be super cool. That would be really fun. I'd be more than happy to contribute to collaborate with anybody who's interested in this stuff. As I said before when we started, I actually thought that when I did this session today, there would only be like 4 or 5 of you on the call. So I'm really surprised that there are so many folks, and I'm delighted. I think it's awesome. I think it's super cool. And I'm glad to know that so many people are actually interested in this stuff. And that was a really loud bang. And I really hope that that you guys, you know, think that this might be useful for your own process. And if it is, feel free to download it and give it a whirl. As I said, there's going to be a major new rewrite coming out by the end of the year, but feel free to try the one that we have right now and see if it works for you. And if it does, you know, just drop me a line. I'd love to chat about it. Love to hear about it. We've got some folks using it already, and I love to hear about their experiences with it and whether this stuff is helping them at all or working or not. You know, so. I will, that was a lot. I know that went longer than usual, but I'll leave it there. I'm happy to hang around for a bit and answer any questions if there are any questions, or if folks have any thoughts or comments about anything.
Yeah.
But thanks again for being here, for everybody.
Thanks, Ed, for your presentation and for the very interesting project you're working on. Don't underestimate what architects can do. And so
never.
But of course, it's mind blowing, like always. And we have a lot of questions. So maybe
cool.
You want to take some of those questions. We can also unmute you guys if you want, and if you want to ask your own questions, we can do so. But maybe Caleb, you start with.
Yeah, there's a whole lot of like interoperability questions that are happening in here, right?
Sure.
Like, right. You know, one is from Thomas Lund. Have you tested out, is there a Revit to Rhino to IDF PHP like workflow? Somebody else was talking about ArchiCAD into, you know, so what's, because obviously like a true BIM as opposed to, you know, something like SketchUp or Rhino, you know, like where large offices are working in things like Revit and ArchiCAD?
Absolutely. Yeah, that's a good question. Well, so there's two answers to that. So first of all, anything that creates an IDF Energy Plus file, so any tool that creates an Energy Plus an IDF file can push that data into the PHPP using these tools. So right out of the gate, if you can make an IDF file from your software, then that data can then flow into a PHPP. So if you're writing it by hand, if you're using Open Studio, I think Design Builder, you know, a bunch of these tools that use Energy Plus would be able to create an IDF file, which could then flow into the PHPP. In terms of Revit specifically, so like say a couple things about that. So like a year ago or 2 years ago, the honeybee folks, the folks making those honeybee Energy Plus tools, they were making multiple versions of their plugin. They were making one for Revit, for Dynamo, another one for Grasshopper. At a certain point, maybe like 6-8 months ago, what they decided was they were going to not do, as far as I understand, they were going to not do the Dynamo work anymore, and they were going to focus on the Rhino and Revit work, or excuse me, the Rhino and Grasshopper work, because the new version of Rhino uses something called Rhino Inside. You can actually run Grasshopper inside of Revit, and you can connect your Revit model to your Grasshopper model automatically. So you can actually pull all of that data out of Revit directly into your Rhino definition, and then it can flow into those honeybee tools and into all the IDF2PH tools, et cetera. So you can automate that relatively straightforwardly using the new Rhino Inside. Now, I haven't tested that myself. That's relatively new. That's part of the new, it's like, you know, 6 months old or something. I haven't tested that workflow, but from what I understand, it works reasonably well. And it works well enough, from my understanding, that the folks making those Ladybug tools decided that they weren't going to make the Dynamo tools anymore. They were just going to make the Rhino ones, because now the Rhino ones could do everything for Rhino and for Revit. So you can basically pull all that data in, all that information. Now, the caution that I would give you about any of that is, and we could talk about this. I'd be interested to hear people's thoughts, but I was just having this conversation with somebody the other day. I mean, my assumption, or well, how do I want to say this? Just because you're pulling that information from Revit doesn't mean that it's automatically going to be correct, right? The downside to that workflow that I see is that whoever made that window family has to have made it in a way that all the right information for PHPP is there. And that's a big if, right? So somehow you have to educate that junior cab operator or the family builder who made the Revit family to encode your, you know, EN 410 or 673, you know, glazing properties or those kind of things. You know, can you do that? I don't know. My guess is you'll probably still end up rebuilding a lot of that model or doing a lot of the encoding yourself. Although maybe I'm wrong. Maybe you can figure out a way to, you know, work with your teams and sort of get that data flowing nicely, which would be super cool. I'd be really interested to see that. But I know with our clients, with the folks we work with, it's always easier for us to just rebuild and encode that information ourselves, rather than try and get them to do that information early on into their building information models. But I totally recognize that that's like a totally wrong way to do it, and it's like a ridiculous thing, but I don't know, it's kind of where we've landed. So in any event, yes, it totally works. You could do it. You can use the Rhino Inside thing. You can use anything that writes to IDF. Any of that stuff would flow through here into these tools. ArchiCAD, I'm not sure. That's a great question. I haven't tested it. I have to admit, I'm not at all familiar with ArchiCAD. I do not know. I don't know what type of file formats that works with, or what sort of connections you can get from ArchiCAD. It's a great question, but I honestly just don't know. I'm not familiar with that software.
There's, if you take a look at the bottom of the chat, there's some pretty, actually maybe too deep into the weeds. And so I'm going to go back to, because there's probably people on here, some more basic things. Can you use could you use a Rhino design model, is being asked, or do you have to create a specific model for what is going on with your, you know, to be able to do this? You need to, like, a more specific model with specific parameters that you're creating, or the overall design model that is being created for?
Well, so that's a super interesting question. That kind of goes to what I was just talking about, right? So the way that the tools are written is that they will absolutely work right out of the box. They'll make a ton of assumptions about what you meant to do. It'll apply a lot of defaults. It'll apply a lot of, so you can absolutely just take a box and make a PHPP model. 100% for sure. You can also input a bunch of information, and it will do its best to adapt that to the PHPP. It'll sort of twist things, and not twist things, but it'll sort of, it's got a lot of adapters which allow you to input certain types of information, and it'll turn it into valid PHPP. For certification though, be careful with that. Right? You have to prove all of those inputs for certification. So just because this tool will sort of make a bunch of assumptions and sort of do a bunch of things that like I thought was smart when I was writing the code, doesn't mean that your certifier will agree with like how this thing converts over your values. So for instance, you know, for certification to PHI, you have to have ISO 10772 testing for your window frames. Well, we don't really have a lot of that in North America. We have NFRC. So if you put NFRC values in, it will do its best to convert that. But don't assume that just because my tool converts things that your certifier will like think, oh, okay, that's good enough. They'll still probably want to see the sort of verification and the testing and all of that kind of stuff. So the tool will do its best to try and take whatever rough geometry you throw at it and make a PHPP model out of it. But you know, sometimes that might not be the appropriate solution. Sometimes the appropriate answer might be, well, actually, no, you haven't given me the right information. But it'll try. It'll do its best.
Yeah, you might want to take a look yourself at the bottom of the chat and
Sure.
see, because like this is beyond, like most of those questions are beyond my knowledge, and maybe you know what they're talking about.
Oh, so hi Prudence. Good to see you. So Prudence had a question there. Which version of PHPP Woofy Pro do Passivhaus tools work with? Do I need to update the tools to new versions of PHPP Woofy where fields mapping have changed? Good question. So, so currently it works with version 9.6. So version 9.6 SI or version 9.7 IP, the PHPP. And Woofy version, what version are we on? I don't even remember. 3 point something.
I think we're 3.2 point like high numbers.
Yeah, that
somewhere
one.
Up there.
Yeah, exactly, that one. And I want to be clear on the Woofy side. The only thing I currently have working is I have geometry pushing in, I have windows, I have shading elements, I have opaque geometry, I have rough materials. There's a really stupid technical hurdle that I just have not figured out how to overcome yet, which has to do with like translating between whatever German and English, and I just haven't had the time to like overcome it yet. There's some really like silly technical things that I just haven't been able to quite figure out, but I'll get it, and we'll get there. So it's totally working.
Maybe I can help you.
Yeah, that would be super cool. I'd love that. That would be awesome. Absolutely.
Awesome.
So yeah, it currently works. And so I had a request just the other day. A colleague from Germany reached out and said, oh, I would really like to use this tool on, you know, German PHPP version 9.2 or something like that. So right now, the way that the tool works is it decides where to put all the data in the PHPP by reading the worksheet names. It says, oh, areas worksheet, Windows worksheet, whatever. And so obviously that's only going to work with the English version right now, but there's no reason that we can't like create a, you know, we can regionalize that. That's totally doable. I never thought about it. It never occurred to me. And so we just need to take the time to do that. There's no technical reason why we can't push that data out to a German language or an Italian language PHPP. You know, that's not a problem at all. We just need to take the time to do the translation there. Oh, go ahead. Sorry.
No, I was going to say this integrated evolutionary solvers, which like that's something like, you know, I have no idea what that is.
Yeah, no, it's an interesting question. So I will admit, when we mostly work on projects, so when we work on most projects, we are not involved during the early form finding phase. That's just a sort of artifact of the way that we've set up our company. We mostly come in at later phases in the project. Once the rough geometry and massing and fenestration ideas have been mostly worked out by the architecture team. And that's, again, just a particular quirk of the way we've set up our company. So we don't do a lot of that sort of form finding. We mostly do optimization work where we're sort of tweaking things and working on assemblies and thermal bridges and all that kind of nerdy stuff. But that said, the way that we've set up the tool is that it's, I think, flexible enough that you could begin using it pretty early in the design phase and begin, as you saw in some of those little vignettes that I posted there, you can really easily add or subtract windows, change sizes. You can absolutely hook into all of the powerful existing functionality within Rhino and Grasshopper in any of those tools can be used to automatically create geometry, to create parametric or different sets of data, and then push that data out to the PHPP. Of course, we have other tools that can actually read data back into the PHPP. I didn't really show those, but if you want to do a workflow like that, where you change a parameter, it pushes to PHPP, PHPP recalculates, then you read that data back in, you can record that data. So we've got tools that allow you to go both directions from the PHPP and also to the PHPP. So you can move data back and forth in that sense, which helps in this sense, right? You can use the PHPP as a sort of calculator, and it happens, I don't want to say instantaneously, but I think at least the new version that I'm writing as we speak, I mean, I'll have that under a second by the time we're all done. By the time we're done, you'll be able to modify a parameter. The whole thing will execute in under a second, provided that you don't have some giant urban scale shading solver to solve. But if you have like reasonable amounts of shading, it should execute in under a second. And you should be able to get that result, pull that back in, and be able to compile. So if you want to try, add a window, subtract a window, do this, do that, it should be able to update relatively quickly. So yes, you could hook into all of those types of evolutionary solvers if you want to do form finding, you want to do any of that type of fenestration optimization, adding windows, changing shading depths, etc., and use the PHPP as your calculator there. I will admit we don't do that kind of work, but I could totally imagine it, and it'd be super cool to see the work that you might do if you want to go down that route. Be really interesting.
It might help for some of the people who are, because it took me a while to understand what was being talked about with the evolutionary solver, but to put it into more plain English, exactly what's going on with, because basically what you're saying is that like the data is optimizing the geometry as opposed to you having to play with the geometry to optimize the data, right? Is that what's going on? That's what's going on with the evolutionary solver?
Yeah, I think that would be one way to say it. I mean, maybe Ryan, are you here? Do you want to add something to that? If you,
yeah, it's basically, you have an output and a bunch of inputs, and it kind of goes through all of the inputs that you set up to find, the ideal one for a certain output that you're trying to achieve. So for instance, if you're trying to optimize energy, demand, you have all these certain input variables, and it's going to run through those to find, the lowest energy demand, for instance. So yeah, that was my question basically. And thank you, Ed.
Sure, absolutely. No, that makes a ton of sense.
So maybe you guys can unmute yourself, as Caleb said, and Chris, maybe you have a bunch of questions there.
Yeah. Hey, Ed.
Hey, what's up, man? Good to see you.
How's it going?
Okay.
This is awesome, by the way. I'm extremely excited. I definitely want to try it out. My first question was, have you messed with like C factors and F factors for below grade
Dude, I don't even know what those are. I mean, I see that in code. I know that they're like referenced in there, but honest to God, like I don't understand how they're made or like what they are. I mean, if somebody here is smarter, I'm sure you probably know, let me know, we can do that. But I honestly don't even understand what they are. I know they're written in code. Okay. Yeah, they're very confusing to me still. It's something about the boundary, or something about the surface films. Is that what it is? Like,
well, yeah, about below grade modeling and and accounting for essentially the thermal bridging at the perimeter, and how you enter C factor and F factor for below grade walls and floors. It's also something that I every time it's brought up, I have to look it up again. I never know what it's going
I mean, I know I see them in the energy code, and I'm always like, oh yeah, C factor. I should probably learn what that is someday. Yeah, no, I don't. Totally.
Okay, if you had figured that out, I would have totally stolen it. And then I was going to ask if you dealt with the output like, can you manage the output variables for Energy Plus directly?
Yeah.
Cool.
Yeah, so we've built, that's a good question. Yeah, so there's a bunch of native Honeybee tools that allow you to manage that. We've also written in a couple of like what do you want to call them? Like presets, where you can say like, well, I'm really interested in, I have one that I use for peak load assessment, where like I want to do an Energy Plus model and I'm not really interested in annual energy today. What I really want to do is focus on peak load assessment for cooling. And so I have like a preset, like as a Grasshopper component that I can drop in, and it changes all of the output variables and the formatting so that I get the type of data that I want. So we have a couple of different pipelines like that we've set up for Energy Plus, where we have presets of output variables that help us, because as you know, that Energy Plus, you get like fire hose of data out the back end.
Yeah.
And you got to kind of wrestle it at some point.
Cool. Very awesome. Then last question. I'm sure this is a long discussion, but just you can run the Energy Plus if you export from PHPP to Energy Plus. You can run it without having to edit the mechanical systems. It basically has a simplified mechanical setup that'll work in kind of a simplified way.
Yeah, yes. So that's a really good question. Yes, it does have a simplified one. So the older version, the version of Honeybee pre-October, had pretty darn simple inputs for mechanical systems. The new version, the version 1 that came out in October, I think has a whole new generation of mechanical system integration. And that's on my docket so as I'm writing all these new components, I'm updating everything. And so I need to make it work with all of those new tools. But like I said, those are only like a month old. So I'm still sort of like figuring out what the functionality is there. So there is a simplified version that exists currently. But yeah, it's not nearly as sophisticated as the kind of stuff you guys are doing with all that Open Studio, node modeling, all that jazz. But there is a simplified version that gets executed. I would say the fresh air ventilation part is pretty good. The part that's not as good is like domestic hot water systems, and obviously heat pump systems. Those are not nearly as sophisticated as maybe we want them to be. So that's all definitely on the docket for future development. Like I said, the new Honeybee stuff I think has some new tools for that, which is super cool. Yeah. So I'm excited to sort of dive into those and learn how they do that in the new version there.
Awesome, so cool. Thanks, man.
Sure, good to see you.
Good to see you too.
And then thanks Chris for the questions. And then Oliver, you could ask your question as well. So the question Oliver had is the PHP interactively all you're doing, or is Rhino involved in that as well?
Meaning like you mean like on the technical side? Like technically, is Rhino part of the that write function? Is that the question? Like technically, how is it streaming? No. Technically, the way that it works right now is that the data moves through something called the Common Language Runtime, the CLR, which functions. It's sort of the active kernel that's running in your system that we can hook into to allow one application to talk to another. So it's the way that we can talk to an actively running instance of an application on your computer. So we don't run that through Rhino in particular. In Grasshopper, using the code that we've written, we can hook into that CLR and we can actually control Excel explicitly from within Grasshopper. So we can start it up, we can close it, we can make whatever, we can make writes, we can make reads, we can do all of that kind of stuff. So no, that's all happening natively inside of, well, it's not really happening inside of Grasshopper. Grasshopper is just hooking into the CLR, and so then we can just do all that write and read stuff. I'll admit that's the slowest part currently. So that's another piece that I'm really keen to improve. The writing to Excel, Excel's a beast, man. Excel's an old program, and there's a lot of dirty secrets hidden in that code under the hood there. And it's not super fast, as we all know. We've all used Excel. And so writing thousands of values to Excel, it just takes a little bit of time. I mean, it takes a second or two every time to do it, which, you want to bring it down less than that. You want to be more responsive than that. So we're working on different ways to have that work better. There's a couple of different optimization tools that we've been implementing there to try and make it work better, but I have a couple others on my sort of like mental to do that I want to try and see if they help us hook into Excel in a more efficient way. That is currently the real bottleneck in the whole process. Everything on the Rhino side and the Grasshopper side runs real fast. And then really the bottleneck right now is that write to Excel. And it's all about sort of just having one application talk to another, or really about Excel. It's just a little bit hard to make it write that many values. But again, there are some optimizations there. We're working on that. We're going to see if we can't get it down faster, because I want it to be kind of like, like running an application. Like you want it to be like fast and responsive. You don't want to sit around and wait for 2 seconds every time you make a small change or something like that.
Caleb, do you see any other question?
There was one from Halbo about certification process, how you put the documentation into together on this, and you've already given us the caveat about the shading algorithm, and I mean, are the certifiers actually accepting this output yet? Or is this still in a
That's a good
beta
question.
phase?
Well, so I mean, the way that it's built, well, I mean, for PHI certification, the only thing you have to submit is a PHPP. So when you're done with all of this, you have a PHPP. So you can go off and use that. You know, obviously you have to collect all the additional documentation and all the other bits and pieces there. You have to prove your work and all that kind of stuff. So that's all super important, but you have the PHPP. There's no technical requirement that you submit a building information a model, at least to, you know, PHI for PHI certification. There's no requirement for that. Now, that's the technical rules. Then, as we all know, there are the rules, and then there are the rules. And so what we have found with our own certifiers is that they want that 3D model. They really want that design PH model. They want to see the shading. They're tired of looking at lists of numbers. They want to see the actual model there. So when it comes to actual in practice certification, while it's not technically required, you know, in practice, many of them want to see that SketchUp model there. We have not found a certifier who likes to work with the Rhino yet. They still want a SketchUp model, so that's fine. So what we end up doing is exporting out the SketchUp model so that they can see the shading and they can see sort of the scene and how the scene is put together. Of course, we make lots of drawings and we make lots of diagrams, but they still in practice seem to want to see that model in the end. As far as the shading, you know, that's why we built that original old-fashioned shading solver. So you still get the old-fashioned shading solver. That's still in there. You know, so the old-fashioned way to do it with the dimensions, like that's all still in there. No, nobody is accepting the new radiance-based method yet, but we haven't really argued the point yet. We haven't really gone to the mat and said, no, this is really better. This is really smarter. I just honestly haven't had the time to do the validation and to come up with the data to support it. It's you know, it's on the back burner. It's like something I keep thinking, oh yeah, I got to do that one day. But I just haven't yet. So we keep defaulting to the old-fashioned stuff and just saying, well, look, that's good enough for certification, you know, for certification process. So it definitely can work. It does work for certification. We use it for certification. It helps us a lot to manage data in certification processes, especially with larger projects. But there is sometimes a little bit of finagling at the end. And in general, you know, we've never just given somebody else one of these models. It's always about outputting something else, a piece of paper with a drawing on it, a SketchUp model, you know, some other thing comes out the backside there.
And then I'm just going to do this. I think we should do this. Will be the last question because I think, you know, we're over time. We should wrap up. But
Sure.
But this, you know, I think, I mean, we could go on. This is really fascinating. If you could potentially share any side-by-side results from a finished model you put through this process, starting with the same inputs, how do the energy plus outputs compare to the PHPP output?
Well, isn't that a good question? Well, as we all know, the PHPP inputs for internal gains are not the right numbers. So that's been known for a long time. And so what we find is exactly what one would predict, is that the internal gains numbers are far too low, especially on the cooling side for an actual North American project. So what we find is that the Energy Plus says that there are higher peak heat loads, or excuse me, peak cooling loads than the PHPP. And to be honest, I believe those Energy Plus numbers because we're using the Pacific National Lab residential schedules. We're using all of the distributed schedules from the 2018 demonstration models. So I like those schedules a lot. I believe those quite a bit. Maybe with the exception of the lighting models. The lighting models seem way overkill given how much LEDs have penetrated the market at this point. So I'm not sure I believe the lighting values, but by and large, I think the occupancy values and the residential equipment usage values are much more believable on the Energy Plus side. Everything else is pretty much the same. The opaque model stuff, or excuse me, the opaque assembly stuff is all the same. The the solar gain stuff is pretty much all the same. It kind of depends on how you slice and dice the shading factors and how you slice and dice the seasons. But the real discrepancy, in my opinion, is all about those internal gains default values. And that's just all about whatever number you input, right? What's your watts per square foot for lighting? And the defaults in the PHPP are just wrong. They're just way too low. And so where that rears its head is, in my opinion, really on the peak cooling load side. Now you can adjust those values, go in and just change the number. It's just that easy. But the default numbers that come out of the box are just not correct for the types of models. They're the types of buildings that we're working on, in my opinion. Now that's comparing software to software. Like compare any of that to the real world, that's a whole different ball of wax, right? Go compare it to an actual building someplace, that's a whole different thing. And I know a lot of you guys are doing that and gathering that data, and that's so awesome and so important, right? To calibrate all these models to actual real world conditions. So you can compare software to software all day long, defaults to defaults, inputs to inputs, but then of course you got to register that against the sort of actual, the actual universe there. So anyway, yeah, super interesting. We've got a little bit of that. You know, people don't ask us to do that very much, to do things side by side and see. But once in a while they do, and that's always a fun exercise to see how these things really stack up. Like I said, in terms of the geometry, the assemblies, the materials, all of that stuff, that's all pretty much same. The solar, that's all same. Ventilation, same. Once you get the equipment all aligned, it's really those internal heat gain rates, which I think is where, at least from my own investigations, that's where we're seeing the big discrepancies there. I saw that Andres had a question there about the shading solver as well compared to Design PH2. Well, it's a great question. I haven't timed it, so I can't give you a number. But of course, you know, I've done enough work in Design PH2. I've used that shading mask method, that sort of reverse ray trace method there. And we all know that if you have a big scene with lots of polygons, that solver is slow. That is a really slow method for calculating shading. Right? It just is. If you use a really high ray count, if you use a high level of you know, a high number of analysis points, and you have a lot of polygons. If you have a big urban scale model, you pulled in something from, you know, OpenStreetMap or something like that. You pulled in a neighborhood scale model. That's a slow ass solver. There is no doubt about it. So the radiance solver that Ladybug is using, well, I shouldn't say it's not always Radiance. There's a couple of different solvers that Radiance actually allows, or that Ladybug allows us to hook into. We can use a couple of different versions of them, but we're talking about going from maybe 15 or 20 minutes for a really high fidelity solution down to maybe a minute or two, something like that, for a really, really complex scene with, you know, millions of polygons. You can do that type of assessment really, really quickly in the Rhino side in a way that would take literally, you know, double digits of minutes to do on the Design PH side. Now that's, you know, your mileage may vary. You've got a different computer with a better graphics card than I do. Sure, yeah, your time frames will be different for all that stuff. But for my own personal work, we've seen huge differences in the time it takes to execute those shading solvers. And then, of course, I should say, you know, the old-fashioned PHPP shading solver, the reason that one was so awesome and stuck around was for so long was because it was fast as hell. I mean, that was an incredibly fast shading solver because that's not really doing any shading analysis. It's doing a curve fit, right, which is a super fast way of doing shading analysis. So that's a really nice way of doing that. It gives us really fast feedback, all but instantaneous. But of course, we're going to sacrifice a little bit on the accuracy side as a result there. So different ways you can do it, right? You've got different tools built in there to use different tools there, depending on how accurate you want to get and sort of how far you want to go with it. So yeah, super good question there.
All right.
Yeah.
Ed, if you don't see anything else, I would say we close out. The session was very, very interesting. It's obviously very important to see the newest things and stuff coming out of Ed's lab, basically. and and we hope to, yeah, we really hope if there's interest to do a more robust course on that new energy modeling tool or link. Hopefully we can do that in the springtime. So if there's interest, we'll organize that and hopefully we learn much more than we have already today.
Yeah, that would be super fun. I would love to do that. If people are actually interested in it, if, you know, the YouTubes isn't good enough and you want to do, you know, a sort of more detailed walkthrough altogether over the course of a couple of weeks or something, that would be super fun. I'd be totally up for that. Like I said, I'm going to be writing the new version over the next couple months. Hopefully by the first of the year, we'll have the new version ready to roll out, and folks can, maybe we can all get together and walk through it at that point. Again, I'd love to hear anybody's thoughts or opinions as you dive into it, if you do give it a shot.
Sounds good. Thanks, Ed, for your fantastic presentation, or for all your work you do for the entire community. And thanks everyone for listening in.
Absolutely.
Thanks, Ed.
Sure. Well, thanks everybody for being here. Great to see everybody.
And have a happy Thanksgiving.
Yeah, absolutely. Happy holidays, everybody. Happy Thanksgiving.